Yeah, the real reason I wanted to stop the video is to wear this t-shirt. Is this? Okay, damn, I'm sorry, no, I didn't think about it. It's just, as I was saying it, I was thinking, I should have worn my t-shirt. But, you know, I was so happy how the video went, and, you know, I don't re-record these, to be honest, because it's like, it's not fair, is it? It's like cheating. You know, it's not a film, it's not a movie. I don't have to do a perfect take. You know, it's kind of, and I kind of like you to see the way things progress naturally, and you kind of see my raw thought processes behind it all as well. Okay, and I can't always recreate that if I just redo it again, just literally a few minutes later, because you know it's not going to be the same, is it? So yeah, when it came to doing this bit, and I was like pausing every now and again, you could kind of see what I was going through. It's less robotic, it's more human. You know, I'm human after all. I pretend to be anyway. What am I going to do next? Okay, because yeah, I didn't just start recording just so I can show the t-shirt in this, even though that's pretty cool. Okay, if I do say so myself. What I want to do is, because it's a really nice equation, I want to look at a Cartesian equation for it. Okay, because there is one that exists. And this is a nice opportunity actually for me to talk to you about how to convert between Cartesian and polar equations when it's a rather difficult one like this. So I'm going to use this. That can have a use. Okay. Now, what do we know? Okay, what do we know? Well, we know that we're going to write it x squared plus y squared equals r squared, don't we? Yeah, we do. Okay, so we can substitute that straight in, you see. So if I want to remember, Cartesian equation has got to be in terms of x and y. You don't want r and theta in it. So we can just get rid of r straight away by writing x squared plus y squared equals that. The a squared, fine. That's just a constant. Keep it there. That's right. The theta, no, we want to get rid of that. What are the relationships we had? We had x equals r cos theta and y equals r sine theta. You remember that? Yeah. Now, think back to parametric equations. What are we going to do with this? Okay, that's in terms of theta, that's in terms of cos 2 theta. Yeah, you need an identity. Okay, trigonometric identities. Which identity are you going to use? Okay, are you going to go for cos squared theta minus sine squared theta? You go for 1 minus 2 sine squared theta? You'll go for 2 cos squared theta minus 1. It doesn't matter which one you use because you're going to get to the same Cartesian equation, aren't you? Okay, so why don't we go for 2 cos squared theta minus 1. Why have I chosen that one, do you think? Pause the video maybe, there's a reason. Yeah, it's just generally when you're dealing with Cartesian equations, it's nice if you've got just one y variable, and it doesn't matter how many x variables we've got, does it? Okay, that's the reason why. Okay, so yeah. So for example, you know, you might have something simple like this: y equals x, you know, x plus 1. We don't care that there's 2 x's there, okay? But we would care if there were 2 y's there. So the reason I've gone for that one is because I'd rather use the substitution for x, okay? So there we go. Oh, there we go. I was just looking at this. Ta-da! There it is. So I'm going to keep this there, the x squared plus y squared, and the a squared, and then 2 cos squared. It's a bit annoying because the video just stopped recording here. It does that every now and again. So yeah, but this is not one I wanted to re-record all over again. Okay, so I rewound the video and I got to there. Okay, so I'll just try and continue as normal. Okay, yeah. Despite me saying don't re-record these, well, if the thing stops recording, I've kind of got no choice, have I? But it doesn't matter because I'm nearly at the end anyway. Okay, so. What was I saying? Okay, sorry if this is repeated. Okay, but I went for this identity here, didn't I? And hopefully I mentioned the reason for that is because when I substitute this in, I want to have the Cartesian form. Okay, and what I've written in here is x squared equals r squared cos squared theta, because then I can replace cos squared theta directly. You see, so I'm left 2 there, and cos squared theta is with x squared over r squared. So x squared over r squared like that. and then subtract 1. So that's that. Now the problem is we've got an r in it again, and it's not therefore a Cartesian equation, is it? Because Cartesian got to have no r's or thetas. It's got to be x and y as the only variables. So you've got to decide how to deal with the r squared. When it's a fraction, simple things just multiply throughout by r squared to get rid of that. So what we're going to do, we're going to have, I want to just sort of rub this out, okay, if you don't mind. Okay, I'm going to multiply both sides by r squared, so I'm going to have r squared, like that, okay, and this is going to become 2x squared minus r squared. Can you see that okay? Good. Alright, I'm so glad you said yes. Okay, so I'm still annoyed about the video cutting out 2 years. Anyway, can't be helped. R squared is x squared plus y squared, isn't it? Okay, so I'm just going to rub that out again, and because it's just x squared plus y squared, it's going to be that. Yeah, x squared plus y squared squared. Okay, and r squared, I'm going to substitute that in here, so it's going to be negative x squared plus y squared, so subtract x squared, subtract y squared. Okay, now that's a Cartesian equation, but we can simplify it a bit, can't we? So we've got x squared plus y squared is equal to a squared, and then 2x squared subtract x squared is x squared, and then subtract y squared. Okay, and then that is it. That's done. See, video didn't miss much, so that's just irritating. Okay, particularly when it was about infinity, because it's like nice. Anyway, yeah, so that's that. So it's nice seeing the Cartesian equation of this lovely Lemniscate, this lovely infinity curve, isn't it? Okay. But as I mentioned a few videos ago, sometimes it's nicer to have polar coordinates because you get a simpler looking equation. That is a simpler looking equation than that, isn't it? Incidentally, you don't want to square root both sides of that because then you'd have the positive or negative, and in an equation that doesn't look as nice. Okay, so you just leave it like this. Okay, and you don't want to complete the square, not complete it, do the difference of two squares and that, because it'll just expand it a bit and make it look a bit longer. Okay. Anyway, so there you go. There's your Lemniscate. There's your polar equation. There's your Cartesian equation. Okay. Yeah, hope that was kind of nice. Okay. I hope you enjoyed that. Okay. I'm just gonna do this so that I can get a screenshot of myself with the t-shirt and that, because it kind of looks cool. Yeah. All of that. Yeah. Next, what I'm gonna do? Integration. Yeah. Integration with polar coordinates. That is really good. Okay. All right. I'll see you later.